11.8 Combinations. A combination is a distinct group or set of objects without regard to their arrangement. The number of combinations possible with R objects are selected from N objects is found by the combination formula. So this is our combination formula. N and R mean things. N, that's always going to be your total, just like with probability. And then our R, that's your selections. So just like we did it before, it's always selection over total. It's still the same numbers, we're just using a formula now. So it's factorial n over n minus r factorial. So example 1, permutation or combinations. A group of 5 friends are forming a club. The group will elect a president and a treasurer. And how many different ways can the president and treasurer be selected? And then B, of 5 friends, 2 will be attending a meeting together, and how many ways can they do so? So we need to figure out, is A or B permutation or combination? For A, since the president's position is different from being the treasurer, because that's what it's asking, we have a permutation problem. Hypothetically, I'm using names here. Hank as a president and Peggy as a treasurer is different than Peggy as a president and Hank as a treasurer. The order of selection matters. So what's important here is that permutation order matters for permutation. Because if I'm president and you're treasurer, that's so different than you being president and me being treasurer. That's a permutation. Now, of the 5 friends, 2 will be attending a meeting together, and how many ways can they do this? There is no difference if Hank is selected and then Peggy is selected, or vice versa. Since the order in which 2 individuals selected to attend the meeting is not important, we have a combination. So when order is not important, then it's a combination. Because if you're just attending a meeting, if Hank then Peggy goes, it's no different than when Peggy or Hank goes, because they're both going to the meeting. But if we select a president and treasurer, that's where things start to actually matter. So that's the difference between permutation and combination. Your American history class, you are assigned to read any 3 books from a list of 8 books. In how many ways can you select 3 of the 8 books to read? So here, does order matter or not? If I select a book, does it matter what next book I select? No, right? It's just going to be 3 of the 8 books. I don't care about the order. I'm just reading them. So because we know that this is a combination. So for combination, we use the formula NCR equals factorial n over n minus r factorial. So let's identify our n's and our r's. So remember, n is always the total. So how many books are we reading? How many books can we pick from this class? Well, there's 8 books that we can read. 8 books. So our total is 8. And then how many of those books are we reading? That's the selection. So how many of these are we actually reading? We're only reading 3 of 8 books. So let's plug it into our formula. We have n factorial, so 8 factorial, over n minus r factorial, so n minus r, that's 8 minus 3. And then r factorial, so 3 factorial. Remember, with factorials, it's 8 times 7 times 5, it's 8 times 6 times 5 times 4 times 3 times 2 times 1. It's in order, but I'll work this out separately with us. So you could use a calculator if you wanted, but here we have 8 factorial, and then 8 minus 3, that's 5 factorial, times 3 factorial. So 8 factorial, remember that's 8 times 7 times 6 times 5 times 4 times 3 times 2. We don't need 1, because it doesn't change anything. And then for 5 factorial, that's 5 times 4 times 3 times 2. You don't need the 1. And that's all being multiplied to 3 factorial, so 3 times 2. We can cancel out identical things. So you see how we have a 5? We can cancel that out. A 4, a 3, and a 2. So what we have left is 8 times 7 times 6 over 3 times 2. You can cancel out the 6 and 3 times 2, but if you don't see that, that's okay. It's okay if you don't see that. But 3 times 2, that is 6, so you can cancel out the 6 and 3 too. But let's say you don't see that, and that's totally okay. It doesn't matter, because you can just work with it as is. So 8 times 7 times 6, that's 336. 3 times 2 is 6, so we divide that by 6, and we get 56. So if you have 8 books and you need to read 3, you have 56 different combinations. Jan has 10 different photos from which she will choose 6 to hang on the wall. How many different ways can she do so? So in here, she's not asking about order or anything. Jan just wants to hang photos. So if she just wants to hang photos and doesn't care about order, this is a combination. So it's a combo. Since it's a combination, we're going to be using our formula for combinations. Now you've had practice with permutations, so go ahead and try this all on your own. Pause the video and try it. Alright, I hope you tried it. If not, it's cool. I can't make you, but I'm hoping you're trying. So our n is always the total amount. So total, she has 10 different photos to choose from. Then our r is always how many are you picking? Well, she wants to choose 6 of them. So let's plug it into our formula. We have n factorial, so n, that stands for 10. Then we have n minus r factorial, so 10 minus 6. And then r factorial, so 6 factorial. Now let's simplify. So we have 10 factorial over, so 10 minus 6, that's 4 factorial, 6 factorial. Now let's break this up. You don't have to break it up, you can use your calculator. But we're going to break this up into 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. We don't need 1. And then 4 factorial, that's 4 times 3 times 2. And that's all being times to 6 factorial. So 6 times 5 times 4 times 3 times 2. Now you're always going to cancel out here. So we can cancel out the 6, the 5, the 4, the 3, and the 2. If you see it, you can. 4 times 2 is 8, so you can cancel out the 8, the 4, the 2. But if you don't see that, it's okay. Let's just multiply it straight across. So 10 times 9 times 8 times 7, that's 5,040. 4 times 3 times 2, that's 24. 5,040 divided by 24, we get 210 different combinations to hang our pictures. So if Jan has 10 pictures and she only wants to hang 6, she has 210 different combinations to do this. Example 4, dinner combinations. So at a local restaurant, dinner consists of selecting 3 items from column A, 4 items from column B, and 3 items from column C. If columns A, B, and C have 5, 7, and 6 items respectively, how many different combinations are possible? So first things first, it tells us combinations, but how do we know for sure? Well, because there's nothing in here that's talking about order. This goes first, this goes second, this goes third, nothing like that. So let's pull out all of the information because we have 3 columns here. Our first column, you can select 3 things from column A. So column A, so you can select 3 out of 5 items. For column B, you're going to select 4 out of 7. And then for column C, you're allowed to pick 3 items out of 6. So in column A, you're going to pick 3 out of 5 items. In column B, you're going to pick 4 out of 7 items. In column C, you're going to pick 3 out of 6 items. So you see how we're putting 3 different types of combinations now together. So we have to do a combination for each column. So let's figure out our combination for column A. So A, we can pick 5. Or sorry, there's a total out of 5 to pick. And we're picking 3 of them. So we're going to plug it into our combination formula. So we have n factorial, so 5 factorial, over n minus r, so 5 minus 3 factorial, and then r factorial, so 3 factorial. So with our factorials, we're going to simplify. So we have 5 factorial over 5 minus 3, which is 2, and then 3 factorial. So you know how to simplify from here. 5 factorial over 2 factorial, 3 factorial, it equals 10. We're just going to do the same thing you've been doing, for example, 2 and 3. So our first column, you have 10 different types of combinations. What about our second column, column B? So for B, you have a total of 7, and then you're picking 4. So we'll have 7, 4. So we have 7 over 7 minus 4, and then 4. So we can simplify this to 7 factorial over 3 factorial, 4 factorial, and we get 35 different combinations. So in column B, you can mix and match 35 different ways. Now, I want you to pause and do column C. Okay, I hope you tried. I hope you tried column C. Let's do it together. So for column C, we have a total of 6, and we're picking 3. So we have 6C3, 6 on top, 6 minus 3, and 3. So if we simplify, we have 6 factorial. 6 minus 3, that's 3 factorial, 3 factorial, and we get 20. So in column A, there's 10 combinations. In column B, there's 35 combinations. In column C, there's 20 combinations. Now, it wants to know how many different dinner combinations are possible all together. So all together, we have 10 times 35 times 20, and we get 7,000 different dinner combinations. We multiplied them together because at the beginning of chapter 11, or end of chapter 11 and 11.5, right, we use multiplication because there's not talking about order here. I don't care about order at all, so that's why we multiply them together. Here is a nifty way to remember the difference between combination and permutation. So counting principle, that's what we just did right here. We just did the counting principle. So the difference between permutation and combinations, permutations are used when order is important. Combinations are used when order is not important. That's literally the difference between the two.